We've been talking about polynomials in class, and we're going to talk about something called the roots of a polynomial. A root is where the function crosses the x-axis. So here's a polynomial of 0th order. It has no x dependence. It's just a constant, y equals 1. It is a 0th order polynomial. It has 0 roots. Here is a first order polynomial. We see here x to the first power, and it has 1 root. It has 1 solution if we set the equation equal to 0. Another way to say that is that it crosses the x-axis 1 time. Here we have a second order polynomial, and we see that it has 2 roots, one here and one here. Here is a third order polynomial. We see that it has a root here, here, and here. So the number of roots, or the number of times the graph crosses the x-axis, equals the order of the polynomial. This is a third order polynomial. This is a second order polynomial. This is a first order polynomial. And the number of times that it crosses the x-axis equals the order of the polynomial. This is something that's some part of a theorem called the fundamental theorem of algebra, which says that the number of roots of a polynomial equals the order of the polynomial. Now, we can easily make the second order polynomial different so that it no longer has any roots, or it seemingly no longer has any roots. Now, if we use the quadratic equation to solve this, we would find that it has roots that are not real. They're not real numbers. They have an imaginary component. So in fact, it does have 2 roots, but they're complex numbers, which we may talk about later on, or you may talk about in your next class. So the number of real roots of a polynomial is at most the same as the order of the polynomial.